Hello and welcome. We're just about done with this lesson, but right now we're on example number 1, right? And we notice that Alexandra bought 2 donuts, 3 cookies. She was charged this much. Brianna bought 5 donuts, 2 cookies. She was charged this much. And it's good to know that the donuts and the cookies cost the same. I mean, if you go to the shop, they charge Brianna something different than they charge Alexandra. That's a little weird, right? But how much does each donut cost and how much does each cookie cost? Now, this is very similar to the problem that we just did. See if you can define variables. We know the quantity, the number of donuts, and the number of cookies, but what we don't know is the cost per donut, the cost per cookie. And for this problem, just to build mathematical flexibility, I'm going to use X and Y because you can use D for donuts, C for cookies. We did it down here, P for popcorn, C. That's fine, but to build flexibility, I'm going to use X and Y because that's what we're going to be dealing with on coordinate graphs. It's good to just be able to do that, right? So I'm going to have X be the cost per donut. I'm actually a bigger, what do you like more, donuts or cookies? What are you more of a fan of, donuts or cookies? And Y is going to be the cost per cookie. I'm more of a, I don't know, it depends, okay? So we have cost per donuts, cost per cookie, right? And let's think about this system of equations that we have here. Let's think about Alexandra's equation first, right? She bought, see if you can write it before I do. She bought 2 donuts, so that'd be 2. It's okay if you could use D and C. It's fine, as long as you can see, all right, this is my D, this is my C, this is what I'm using it for, all right? And she bought 3, cookies, for a total is 330, right? And see if you can write Brianna's equation with X and Y variables or whatever variables you chose. I'm going to say she chose 5 donuts, 5 number of donuts times the cost per donut plus 2Y is going to give me a total of 495, right? 5x is 5 times the number of donuts, is the total cost of Brianna's donuts. This is the total cost of her cookies. This is her total cost overall, right? And now what we're going to do, this looks familiar. This looks a little familiar. I see a system here. So I'm going to go to the side, use my different colors, stay organized. Notice how I'm trying to, and I don't have the nicest handwriting in the world, but notice that Mr. Lyons is trying, right? I'm trying out here in these streets. I'm trying, right? And I like to write my positive sign even though there's not one out there, right? Now, I can solve this system. I have a couple ways to solve systems, but for this particular system with my coefficients lined up, I think I'm going to use what? Elimination, right? And if you feel confident doing elimination on your own, go ahead and do that. 2 times 5 is 10, 3 times 2 is 6. I'm going to eliminate my y's because that's my lowest common multiple, right? So I'm going to have to multiply my, and what I'm going to do and what I'm going to want here, right? Be very careful. What I'm going to want here, since I'm eliminating my y's, I'm going to want a positive 6y and a negative 6y. It doesn't matter if you would put the negative 6y on top, just be careful, okay? But now what am I going to have to multiply my top equation by to get positive 6y? I'm going to multiply that by 2. Should look at my distribution like a boss, right? It's going to be positive 4x plus 6y equals 3 times 2 is $6. 30 cents times 2 is 60 cents, right? If you feel confident, pause the video, try to do this on your own, all right? And I'm going to have to multiply my bottom equation not by 3, but by negative 3. That's right. Be very careful there, all right? It's going to be negative 15x minus 6y equals 4 times 3 is 12. 95 times 3, do this, you have a calculator, right? This is going to give me negative $14.85, right? And now I can combine these because I can eliminate my y variables. Negative 11x equals, do the math on your own, and this is a 14, not a 19, I'm sorry. Looks like a 19, let me get a little more organized. You use your calculator. Positive 660 minus 14.85 should give you negative 8.25. I'm going to divide by negative 11. The cops are coming after me because I'm giving you all the secrets. I'm giving you all the methods right now, right? It's going to be positive 1. X is going to be equal to what? Positive negative divided by negative 75 cents. Now, what does this represent in the context of the problem? Come on now. Let me teach my kids. So while that's going off, ask yourself, what does this represent? Well, X is the cost per donut, right? Cost per donut, not donuts. Cost per donut. So that's cost per donut. Cost per donut is 75 cents. That's all you got to say to yourself. Cost per donut, X is 75 cents. But now I want to find the cost per cookie. Do you know how I can find the cost per cookie? Come on now, find the cost per cookie on your own. I'm going to find my Y now because my Y is the cost per cookie. See if you can do that on your own. You can use either the top equation or the bottom equation. See if you can find Y. On the next slide, I'm going to have a key with how I found Y and my check. Please try to do this on your own. Try to find Y on your own. Please try and check it on your own. Please, before you go on to the next one, challenge yourself, all right? Thank you for watching. Thank you for listening. The future belongs to those who prepare for it today, and I will see you later.